Now let's talk about CP violations and have some idea of CPT theorem. And and this this CP, what we call as uh, charge conjugation and parity. This this C and P, it basically refers to the discrete symmetry of nature. And it's given by the product of the charge conjugation C and the parity P. And this charge conjugation C, what it does basically, it transforms. It transforms a particle. If you have a particle, it transforms this particle into its corresponding antiparticle. So if I have a particle P, and this charge conjugation operator, what it does is that it transforms it to its corresponding antiparticle. Or we can say that it transforms matter. It transforms matter into antimatter. And talking about this parity is again a transformation, and what parity does is that it inverts the space coordinates. It inverts space coordinates. And that's purely understood that if we have a coordinate system where we have x, y, and z, what it does is that it inverts x coordinate into its minus x, it inverts y coordinate into its minus y, and it inverts z coordinate into its negative of z. So it basically gives a mirror image of the space coordinates that we have. Or now, when this CP transformation that we have, when it is applied to matter, now if I assume that we have a material particle, and this material particle is moving with the velocity v. Now we have a matter, and this matter is moving with velocity v. What this CP transformation does is that this it converts it into the antimatter, and this particle which was moving in the positive direction, say for example a positive direction of x. What we will get that this particle will be moving in the negative direction of x. So we will have minus v. And if we assume that this particle is an electron, and this particle is moving with velocity, it's moving with velocity v, it will be transformed. This electron under CP transformation will be transformed into a positron. And its motion will be it will be moving with the velocity of minus v after we apply CP. Now since both strong and what we have is electromagnetic interaction, both of these interactions are symmetric. They are symmetric under charge conjugation, C, and they are symmetric under parity, P. So I can say that they must be symmetric under the product of C and P. Now independently they are symmetric under C charge conjugate operation, and they are they are symmetric under the parity transformation. So their product, the product of this C and P, it should also be symmetric. I mean, the strong interaction and electromagnetic interaction should also be symmetric under the product of C and P operations. That should be the case. But at the same time, the weak interactions, they are not symmetric. Weak interactions, weak interactions are not symmetric. Sorry, my handwriting is very bad, and that reflects in whatever I'm writing on this page. So what is important here is that these weak interactions, they are not symmetric under the CP transformation, because what it does is it violates both charge conjugation and parity and parity symmetries that were demonstrated. Now, talking about the CPT theorem, C, P, and T theorem. Now, C is for charge conjugation, P is for parity, and T is for time reversal. Now, what this theorem states? This theorem states that if the three operators that we have, C, that's charge conjugation, and P is parity, and T is the time reversal. So speaking about charge conjugation, I mean, what it does, it inverts the charge, and what P does, it inverts the space coordinates, like x to minus x, y to minus y, and z to minus z. And time reversal, where we have t replaced by minus t. Here we have x replaced by minus x, y by minus y, and z by minus z. And here what we have, q is replaced by minus q. And if all the three transformations that we have, if all the three parameters are utilized or applied simultaneously to a matter, now applying the three transformations to matter, what it does is that in some kind of state, what it does, it converts this matter into the antimatter state. So applying CPT on a matter state, what it does, it transforms into a state of antimatter. What it means basically is that if CPT theorem is valid, then the existence of matter implies the existence of antimatter. This is what it reflects. If this set of transformations is not violated, then for matter there is existence of the antimatter, and that too in the same universe, that too in the same system. So what are the consequences of this CPT invariance that we have is, I mean, we have a stable particle, okay, and this stable particle has a mass, and its mass is exactly same as that of the mass of its antiparticle. The lifetime of unstable particle, if we have unstable particle, its lifetime is equal to the lifetime of the antiparticle. So same mass and same lifetime. And talking about magnetic moment, I mean magnetic moment of a particle, and this magnetic moment of particle is equal and opposite to the magnetic moment of its antiparticle, right? And there are correlations. I mean, the relations that exist between the spin of the particles and the statistics that's involved with these particles. So we have spin statistics, and we also call it statistics theorem. And what is it is, for example, we have particles having integral spin. We call them as bosons, and the particles that obey a statistics, the particles that we call as bosons,